Welcome to your guided Solidworks milling operation walkthrough. In this tutorial, we'll take you from a blank part to a complete, feature-rich component using powerful tools like Boss Extrude, Cut Revolve, Cut Sweep, Revolve, and more. Let's begin. First, we start by opening a new part file in Solidworks. Then, choose the front plane and begin it to desketch. This will serve as the base of your design. Next, sketch a rectangle. Now, go to Features, find the Boss Extrude and extrude the shape upward. This will form the solid base of your part. Create a new sketch on the surface. Draw a circle. Go to Features, find Boss Extrude and extrude the circle. Sketch a rectangle profile at the midpoint of our new surface. Use revolved cut to carve a groove around the base. Draw a rectangle profile using it to desketch. Then create a new sketch which is a line perpendicular to the profile that will act as the path. Use Cut Sweep to sweep the profile along the path. Select the top face and convert the identities. Then, offset the identities. Trims the unnecessary line. Go to Features and find the extruded cut. Then, set your depth and confirm. On the selected surface, sketch a rectangle profile. Use Features and find the Revolve Boss A base and revolve it around a vertical axis. Draw a rectangle profile. Then, sketch a line as your path that's perpendicular to the profile. Next, apply Sweep Boss A base in the Features tab. Use the Fillet tool to round edges for safety, strength, or better aesthetics. Select edges or faces, choose the radius, and confirm. Go to Features tab, find Reference Geometry, and select Plane. Define a new plane. These plane will act as our mirror plane. Select the features to mirror and Solidworks will duplicate them across the plane. Then, select the surface for new sketch. Use the Slot tool from Sketch tab. Define the width, length, position of the slot using the Smart Dimension tool. Select the sketch. Then, go to Features and find the Extruded Cut feature. Set your depth and confirm. For repeated cuts or protrusions, use Linear Pattern. Choose the feature, define the direction, spacing, and number of instances. Perfect for repeated slots. Now that our part is complete, let's move into CAM. Go to the Solidworks CAM. Select Define Machine and set the machine type to millimetric. Then, define coordinate system. Open the Stock Manager. Choose bounding box or custom dimensions to match your raw material. You can offset it for top or bottom clearance. Under Setup, define the origin or machine 0. Usually, this is the top of your part or stock. Forgot to mention that we should define materials first before sketch the 3D design. Click Extract Machinable Features. Then, click Generate Operation Plan to define the machining steps. Next, click Generate Toolpath to produce tool motions for each operation. You'll see strategies like facing, rough mill, contour mill, and drilling automatically created. Before machining, simulate the process using Simulate Toolpath. Watch the cutter remove material and check for collisions. After that, click Save CL File, then save that file in the folder. Finally, post-process the operations to generate G-code. Save the G-code as a tape file. Then, run the G-code before click Confirm. This is a result of the CL file. And this is the result of the G-code that's ready to export for CNC. That's all from me, and thanks for watching.